Hey, have fun.
Thank you. So, at the beginning, I'm apologize for my Froglish because I come from Paris. So, my name is Sebestian. My handle on Twitter is Sebdriven. If you like the presentation or not, you can write me on my email or directly on Twitter. I'm malware analysis, a reverse engineer, and forensics incident handler. And I participate on many projects like Onenet project, BotConf, and many stuff open source like Yeti. Yeti is a threat intelligence platform to collect, share, and make correction on IOC, on entities, on a campaign, whatever. And our stuff are directly on my GitHub, so you can share, you can make peer on my project or on a Yeti project. So you're welcome to participate at the open source, my open source project. So this morning I talk about malware and specifically Windows malware, because I'm not a specialist on Linux malware. It's a bit magical for me, but on Windows. On Windows, it's I reverse many malwares, and here we talk about PE format. PE format is a binary format on Windows, so you have different characteristics of this format, and it's very useful when you make reverse and when you try to make machine learning, because I say try. We speak about clustering. I define the difference. Clustering and classification is not the same approach and the same thing. So I'm defining the difference between clustering and classification, and the algorithm behind this kind of algorithm. And at the end of the talk, I show you where after machine learning how to create Yara rules to make hunting to discover another malware on your families when you find with machine learning. So a little definition about PE formats and executable formats on Windows to understand how to make vector features after for machine learning. So PE format is described by on IMSDN by Microsoft. So you have different layers. The first layer is the most known. It's MZ format. It starts with magic number MZ blah 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 in X. If you make an X dump on the file. After you have those segment. It's for the compatibility of old Windows. You have PF format, and after you have the table of sections. Table of sections describe the different section of your executable, and in section you have the code, you have data, you have import tables to information to execute on the computer when you click it. On the executable, or directly mapped on memory, because you can on Windows you can execute an executable file directly if it maps in memory. without clicking on it. In headers, you have different interesting information. You have the size of headers. You have principal 2 headers, optional headers and file headers. You have the number of sections. In median, you have 3, 4, or 5 sections in exe windows. If you have less or more, it's a bit strange. It can be a packer, it can be an obfuscation method to hide code. You have the address of entry point. The entry point is the first instruction when you launch the exe. In headers, you have the information if your file is a dynamic library, it's or a driver or executable file, because the PF format is used for 3 kinds on Windows. The different on drivers and executable file, you have a main method to start the code of your exe. In a driver, it's like that. DLL, it's the DLL main. It's the first piece of code when you start the exe. So it's the same format, but it's not the same characteristics to use it. For library, you have for DLL you have export function to use with another program like on Linux or macOS. You have timestamp, the compilation timestamp, and the different information about architecture. If your exe can be executed in x86 or 65. The linkers information and many information about execution, the size of the page, the size of section alignment on memory. So in the header you have the kind of information. Just after this, the headers, you have data directory. On data directory, you have 2 information: the size of the table and the virtual address where in the exe is the table is stored. And the sorting of the data directory is the same. He starts at 0 and he finish at 15. So you have export table, import table. Export table, if you develop a DLL, it's your function to use by another program. Import table in the function used by the exe to execute correctly on your computer. For example, a create file or open process or create thread. All function is directly stored in import table. You have resource table. Resource table is the string of your software or the icons, image. If you whatever different of the piece of code. The table exception, certificate table. If you are a vendor and you want to sign your software, the certificate is stored in this table. You have the relocations tables. It's the recalculated addresses of imports to use by the exe, because you have address on your operating system, and it's directly directly copying on the recollections tables. You have information about debug. It's PDB. The path of the PDB it's in stable. The copyright, the thread table, the configuration table, the IAT. The IAT is the address of the import function if your system has ASLR addresses. It's a mechanism to randomize the address when your operating system starts, to mitigate exploit and return to program to execute shellcode. Okay. In section, you have the section is a piece of parts of exe mapped in memory. So it starts at the disk and finished in memory. So you have many information interesting, like size, like characteristics. Characteristics if your section is readable, executable, or writable. For example, when a malware make a run PE mechanism, it creates a memory page with the 3 permissions: read, executable, and writable. Why? Because when the run PE mechanism starts, he push shellcode or directly an exe on the memory page. So you must to have writable rights to write correctly in memory the shellcode or the exe, and read to jump on the exe, and executable because it's a piece of code, shellcode or exe file. Another thing interesting in the name of the section, because many packers, commercial packers, has a name on section like UPX, like ASPAC, like VM Protect. So it's interesting to have the name of the different section and the addresses to map on memory. Another information correlate with section is the entropy of section. The entropy of section is the information quantity in the section, and in the different software calculates entropy. The entropy is between 0 and 8. 0, you have many characters repeated, like nop, 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 or 0, 0, 0. And it's 8, it's your section is encrypted, because the information is totally random in if the section has 8. So with entropy, we can make an histogram on our file to detect the different variation of entropy, or directly on the section in the code section or data section, or overlay. If you have an overlay with entropy with near 8, your overlay is encrypted by symmetric algorithm encryption like AES or like RC4. So when you make reverse, it's very interesting information to start if you have an entropy at 6 or 7, it's obfuscation methods like XOR, because XOR is not really an encryption method, it's just a bit flip between a key and the data. But if you have an entropy is more at 7, it's probably encrypted with RC4 or RS. Ange Albertini, named Corkami, make a good poster to detail all information on P format. So you retrieve those the header section, those headers. It's very interesting to if you want to develop a parser or to understand the format of P. It's on you can retrieve on corkami.com the different poster. It's very useful for the reverser and the people interested by the file format. So, a few words about machine learning algorithm. Machine learning algorithm and machine learning in general is a nutshell. Many people speak about machine learning to detect automatically 0-day, O-day, new malware. It's used by many companies like CrowdStrike, Endgame, but now for many vendors, machine learning is used for the detection. Is not used for clustering or classify malware because it's very difficult to have a good algorithm to classify a dataset without knowing the data in the dataset. And so if you take the dataset Amber, for example, of Endgame, is used for the detection, not classification. Like that, the result on VT, for example, it's a confident result. It's not a name of malware or so. It's probably a malware 90%. So it's a score if the software is trusted or not. In machine learning, we make the difference between clustering and classification. Clustering, you have a data set without knowing the data, and you try to make different clusters, and each cluster is the same family. It's very useful for in biology to classify flowers. At the beginning, this algorithm is used to classify flowers, not malware. So the features using is not the same, and we have not the same problem with flowers and malware. The classification, you have a dataset, and all data is labeled. You have a label on each data. So if you take the Amber dataset, I speak about Amber dataset because it's open source dataset. So you can clone it, you can use it and play it. So I prefer to speak about open source dataset because it's more simple to make your own algorithm. And you have three labels: the label 0 for the goodware, the label 1 for the malware, and the label -1 because it's not a malware, it's not a goodware. And the algorithm learn on this label and this characteristic. So if you put a new element, the result on the classification, it's the new element as the 0 label, 1 label, or -1 label if the algorithm can't classify correctly the file. So it's the classification. The problem with the classification, if you play with malware, the first one is the packers, because statically the packers change the properties of the binary of the exe. So the first one, when you make classification or clusterization, you clusterize packers. You have to leave these IDs. You classify packers. So for the APT, the different APT didn't use packer. So you classify correctly the real binary file. You don't classify the packer. If you if you want to classify Trojan bunkers or another like that, it's a bit complex, because this malware use commercial packers like UPATR. UPATR, it's a commercial packers, and on the exe you have different methods to download but it's not the real payload. The payload is on the exe or another server. The packers download the real payload and execute the real payload. And another problem is different people developed exe with the same particularity of packers, with the same particularities of malware, but it's not a malware, it's not a packer, it's just for joke. And we have an exe very famous on VT named VT-Floater. The only function of VT-Floaters when it executed by the operating system is to upload on VT with a new hashes. So if you're monitoring with Yara rules this VT-Floater, you have 5,000 Unix file in a day. If you take the dataset of Amber, you have 10% of the dataset is VT-Floater. But it's not a malware, it's just a piece of code to annoy the analyst. So when you start the classification and start the clusterization, you must know what you have in the dataset. Another tool interesting, it's AVClass. AVClass make clustering. It's a classification, it's not clustering. It use classification about VT report, and he create families with VT report. The only problem, if its family is unknown, it classifies the file on singleton. So you must create your own family on the new malware. And classification is very good to detection. If you execute Amber data on the Amber dataset, you have 98% of detection. So it's a good stuff. But if you try to make clusterization with the dataset, it's very painful, very painful, because the dataset is not made for clustering, but it's made for classification. And the clustering, it's better for hunting, because when you make hunting, you don't know the malware do you want. You create different rules, and you can find a new families with an old rule Yara, for example, and like Costin explained before me. So for clustering is better for hunting. The algorithm used for classification is supervised algorithm, because you specify the different label and the different family of your dataset. For clustering, we speak about unpervased algorithm, because we don't know the different label on the dataset. The input on machine learning, it's a vector of features. Vector of features, it's an array to describe properties on the file. For an exe, you have the size, you have the import tables, you have the number of sections. So you create an array with this different information, and you create a list with all arrays for all files. So you have a matrix with shape the numbers of your of the files, and the dimensions of features, the number of features. So if you have 100 file and 5 features, you have a matrix with shape 5 by 100. And we use this concept. If you have a malware, you transform your malware on vector features. You compute a distance between the vectors, and if the vectors is very near, you have a similarity. So if you have a similarity, the malware are near. It's very simple. And we use the Euclidean distance. The Euclidean distance is the distance we use on the live when you go to Belfast of Dublin, for example, or is in France kilometers. Here is miles. And in this presentation, and to understand the concept, we have mixed the concept of labelized dataset with algorithm unpervased. The goal of that is to verify if the featuring is good or not. Because the key of machine learning is to make a good featuring to describe the property of your files. Malware and clustering. The goal of clustering is to create signature for make hunting and minimize false positive. And I am using that for hunting different campaigns, malware. The first case of clustering is SSDeep. Everybody knows SSDeep? Ashes? Okay. The big problem with SSDeep is the chunk size. If your chunk size is equal at 0, the algorithm, as a result, your malware don't match. The problem, if you have a section with many randomly data, and this section it doesn't use execution, you have two SSD different, and with a different chunk size, but it's the same piece of code. Many researchers compute SSD hashes on the section of code, because the section of code normally didn't change. Another concept, it's a PAH. PAH use a complexity of Kolmogorov. The problem with PAH is not a real, you don't compute a similarity or a distance between file. You have a hash, and you have one hash for a family, but you can't compute distance between family. Another concept is ImpHash. ImpFuzzy is very useful to make hunting, but it's not enough if you if, for example, you have another function on the import table. You have another case named Polichombr, Machoc, or R2 gravity. The problem on this algorithm is the complexity of computation, because you compare 2 by 2 malware. So if you have 100 malware, you have 10,000 comparison. You have a quadratic complexity. So for scaling, it's if you have a big data set, it's a real problem. So here we use DBScan and Camins. It's two algorithms you can use with scikit-learn. It's a Python, so it's very simple to use it. And for the dataset, we use the zoo. Is a dataset open source with different binaries, malwares with different family. The goal is to construct the best vector features, and after the clusterization on each in cluster, create Yara rules. So it's mathematics, so it's not very interesting. The start of the algorithm, you choose a number of clusters at the end. So you test. You try a first loop, and if you don't have a good result, you will try. The algorithm choose the centroid. The centroid is the center of the cluster. Means create groups, and each groups you have a center named centroid. And when the algorithm choose centroid by the criteria inertia, it computes all distance with this centroid. And if a vector is more than another centroid, it say, okay, I put this file in this family. Yeah, I explain that better here. So you can create different family. The problem is the border. because on the border it's not simple to have a good classification. DBScan in another algorithm, he use the density to create balls to make clusters. So you have and in black it's the noise. The noise it's a file. The algorithm can't classify correctly this piece. So it's very, very interesting to know if you have noise or not. So in Python it's very simple to use. It's just that you choose a metric, the number of jobs, and the parameters. So you try parameters. Like HF, you on cooking you choose your parameters to have the best classification as a result. Featuring. Here we have a very simple featuring: the section, import, export, and size of file. So we create an array with different featuring: median of entropy, number of sections, size of file, number of import, number of export. That's all. Oh, sorry. For k-means, we have many families. The first family is the family 0, and you have a big clusters with equation group droppers. Just like that. But you have different ransom loci. You have mixed, but in the first approach, you have a good clusterization. In others, in the families with less 10 samples so you have many families with you have 1, 2, or 3 malwares because the dataset is very heterogeneous. If you sorry for the French, here it's family. And here you have 2 big family with equation group. So the first featuring has a good classification, but it's not real a good representation of the dataset. The problem it's we don't normalize the vector. The normalize is the length of your vector. So you can divide by the max of each values to normalize the vector. So size file divide by max size all of file, and you have all values between 0 and 1. If you divide by the norm, not absolute norm, but the norm, you have the value between -1 and 1. It's a ball, and all the value are in the ball. And now, after, we have a better classification. We retrieve a new family. This family has just one family of malware. Here, you have a big family, the Bavaria Ghost, but you have different. It's because it's use the same packer between this family. But in DBScan is better, so you have different family with only family on malware. You have equation group, volatile stellar explosion, equation group, and the different family between equation group is a different version of droppers. So now we have a good classification. on the different families, just normalize with simple vectors, just normalize the values between 0 and 1. And on this clustering, we use Yaragenerator on the family 0, and you create a rules with these Yaragenerators. And on VT hunting, we found a new equation group, malware, and this week we have found 5 new files on VT on equation group malware with where the Yara rule generates on my clustering. And the best way, we don't have false positive. When I make a recurrent on VT, I have no false positive. So my Yara rules, it's very, very good to detect this family of droppers. Conclusion. Machine learning is not magic. The best way is to make a good featuring, and you must normalize your data before make clustering. And you make many tests before have a good result with machine learning. So thanks for your attention. If you have a question.
Are there any questions now in the room? No questions for now. Maybe you can take them outside. If somebody has a question, just find him. He has an awesome hat on, so he's easy to spot. So thank you again.
Thanks a lot.
Awesome.